Welcome back all my dear students of the primary 6, and today to the last part in unit 1, lesson 1, mass and weight. Now to the last factor affecting the weight. The last factor affecting the weight. We mentioned two factors before. Number one, the mass of the object. And we said that by increasing the mass of the object, the weight will be increased according to the rule, weight on the earth equals mass times 10. The second factor affecting the weight is the planet where the object exists. The planet where the object exists. And we said that Jupiter has a greater mass than the Earth, and the Earth has a greater mass than the Moon. So the gravity on Jupiter will be the greatest gravity. Jupiter has the greatest gravity because it has the greatest mass. The Earth is greater in mass than the Moon. So the gravity on the Earth will be greater than the gravity on the Moon by 6 times. So the ability of any planet to attract the objects to its center depends on the mass of this planet. The planet that has a greater mass has a greater gravity, has a greater ability to attract the objects downward. And now to the last factor, which is the distance between the object and the surface of the Earth. Before we talk about the last factors, I want you to look at this person. Here we have a person. This person is in a flying balloon. As this person is flying in the balloon or in a flying balloon, he is away from the Earth's surface. He is away from the Earth's surface. He is moving up away from the Earth's surface. The distance between his body and the surface of the Earth will increase. So we say that as we move away from the surface of the Earth, the gravitational force or the ability of the Earth to attract our bodies will decrease. A person in a flying balloon, he is moving away from the surface of the Earth. He is moving away from the surface of the Earth. As he moves up, the distance between his body and the surface of the Earth will increase, and he will be less attracted. The ability of the Earth to attract his body will decrease. The ability of the Earth to attract the body of this person who is in the flying balloon will decrease, because by increasing the distance between the object and the surface of the Earth, the gravitational force will decrease and the weight of this person will decrease. So the person in the flying balloon will have a smaller weight, because as we move away from the Earth's surface, the gravitational force decreases and the ability of the Earth to attract our bodies will decrease. So we can say that by increasing the distance between the object and the surface of the Earth, the gravitational force decreases and the weight will decrease. But for the same person, when he moves down and he stands on the surface of the Earth, his weight will increase because he is nearer to the center of the Earth. As he moves up, he will be less attracted. The gravity will decrease, the weight will decrease. So, the weight of a person in a flying balloon, the weight of a person in a flying balloon is smaller than the weight of the same person on the surface of the Earth. On the surface of the Earth, he is more attracted to the center of the Earth. But when he moves up, the gravity or the control of the gravity will be decreased. You can say that in a very simple way. I can say that as we move up, we escape from the effect of gravity, but our bodies are still attracted. We don't flow or we don't move in the space. We are still attracted to the center of the Earth, but as we move up, the effect or the control of the gravity on our bodies will decrease. So in the flying balloon, he is less attracted to the center of the Earth, and on the surface of the Earth, his body or the weight of his body will increase because the distance between the body and the center of the Earth decreases. So in the flying balloon, he has a smaller weight. If this person falls down here, his weight will increase. His weight will increase. He will have a greater weight on the surface of the earth because as we move away, the force of gravity will decrease. So in the flying balloon, he has a smaller weight. If he falls down, his weight will increase because he will be more attracted to the center of the earth. And this is the relation between the distance between the object and the surface of the earth and its effect, or its effect on the weight or the gravitational force. Let me repeat what we said before in a one sentence. Here we have a person in a flying balloon. In the flying balloon, he is moving away from the surface of the earth. As we move away from the surface of the earth, our body will be less attracted to the center of the earth, and as the distance between the object and the center of the earth increases, the ability of the earth to attract our body will decrease, and the weight will decrease because the weight is the force by which the body is attracted to the center of the earth. Move up, the weight will decrease. Move down and come nearer to the surface of the earth, your weight will increase. So, this is the conclusion. I want you to read this conclusion and to try to understand it. The weight of a body decreases when the distance between the body and the center of the earth increases. The weight will decrease. The value of weight will decrease when the space or the distance increases, and the gravitational force, as we move up, the gravitational force will decrease because the earth doesn't have enough gravity to attract our body. We are still attracted. If you move up, you are still attracted to the center of the earth, but the gravity will decrease as you move away. I can say I'm escaping from the effect of gravity, but I'm still attracted. But I'm just trying to decrease the ability of the earth to attract my body downward, okay? I have a question now, and I want you to read it well and tell me what is the right answer for this question. Give a reason, and let me tell you that in most of the science exams, you may find this question. I want you to read it well and try to answer it. You have 1 minute. Okay, the question says, the weight of a person in a flying balloon is smaller than his weight on the Earth's surface. The weight of a person in a flying balloon is smaller than his weight on the Earth's surface. Do you remember? If we move up, away of the center of the Earth, what will decrease? The gravitational force will decrease, so the weight will decrease. So, in the flying balloon, he is away of the surface of the Earth. He will be less attracted to the Earth. His body will be less attracted to the Earth. The gravitational force will decrease, so the weight will decrease, and this is the right answer for our question. So, because as we move away from the Earth's surface, the gravitational force decreases, so the weight decreases. And we know that weight is a gravitational force by which a body or an object is attracted to the center of the Earth. As you move away from the Earth's surface, you will be less attracted to the center of the Earth, and your weight will decrease. Let's compare for evaluation of your session. As an evaluation for your session, let's compare between mass and weight. Number one, I'll start with the definition. We all know the definition means the meaning of each one of them. What is the meaning of mass? What is the meaning of weight? The second point of comparison is measuring units. We have 2 units for measuring the mass. The measuring devices or the measuring tools for mass and for weight. The direction of its effect, the direction of mass and the direction of weight, and finally to the effect of a changing place. The effect of a changing place on the value of mass and on the value of weight. This is your time to test yourself. Write this question and try to answer it. But I'll give you the answers, or let's answer it. We have the same table of comparison. For mass, mass is the amount of matter in an object, as we know. The meaning of weight, weight is the force by which a body is attracted to the earth. For the measuring units of mass, we have 2 units, gram and the kilogram. Gram is used for the small masses like gold, silver, diamond, and the expensive or the precious objects. For fruits and vegetables, which can be considered as large masses, we can use kilogram. For the measuring unit of weight, we have only 1 unit used for weight, and we know that it's named after the scientist who discovered the gravity force. This scientist is called Newton. For the measuring tools or the measuring device of mass and weight. For mass, we have 4 devices. Do you remember? We have 4 devices can be used to measure the mass, but here I mentioned 1 device, which is the balance scale. But we have 1-arm scale with pointer, 1-arm digital scale, and sensitive scale. And for the measuring device of weight, we have only 1 device can be used to measure the weight, and this is the measuring device of weight, which is called the spring scale. The spring scale. For the direction of its effect, I start with the mass. Mass has no direction. Mass has no direction. But the direction of weight, or for the direction of weight, all objects are attracted downward by a force called weight or gravity. So the direction of the weight is downward to the center of the earth. The effect of a changing place, what may happen to the mass and the weight if we change the place. We know that mass is not changed by changing place. The mass is a fixed value or stable value. Doesn't it change by changing place? But the weight is different from one place to another. The weight of my body on the earth is not equal to the weight of my body on the moon, is not equal to the weight of my body on any other planet. So the weight is different from one place to another, and this is for the answer of this question. And now it's time for your homework. If the weight of your body on the Earth's surface equals 600 Newton, calculate the mass on the Earth's surface, the mass on the Moon's surface, and the weight on the Moon's surface. In this question, I want to explain a very simple idea. We all know that for any object on the Earth's surface, we can measure its weight through a mathematical rule, which is the weight of an object on the Earth's surface, weight on the Earth equals mass measured in kilograms. Mass in kilograms times 10. Mass times 10. But here we have the weight. You have the weight on the Earth's surface, which is 600 Newton. We have the value of the weight. The value of weight here is given as 600 Newton. Do you know the value of mass? No, the value of mass, we don't know it. I put it as a question mark. So, weight equals 600, as we have from the problem, equals question mark, because we don't know the value of mass. Multiplied by 10 or times 10 equals 600 equals mass multiplied by 10. Let me tell you about a very simple way to answer this question. We have something called the magic triangle. The magic triangle is a very simple way to answer this question. We have the weight on the earth equals mass multiplied 10. So I'll make it bigger to be more clear. I'll clarify it more for you. Here I have a triangle. I know this is your first time to answer this question, so please try to pay attention with me. We call this triangle as a magic triangle. We have the weight on the earth equals mass multiplied 10. So here I put the weight on the earth. And here I put mass times 10 or multiplied by 10. What do we want to measure here? We want to measure the mass of the earth. So the value that we want to measure here is the mass of the earth. Can you hide it? Can you put your hand on the mass and read this triangle? How can I read the triangle? Mass on the earth, you will put your hand and cover it like this. Mass on the earth will be equal weight on the earth divided by here. It means divided by. So the mass on the earth that we want to measure will be equal to the weight on the earth divided by 10. Weight on the earth divided by 10. So what if we want to measure the weight on the earth? Let's make sure of this rule. Let's make sure. خلينا نتأكد من الرول دي. يمكن تكون غلط. خلينا نشوف الماجيك تراينجل هيقول لنا ايه. I put my hand here. The weight on the earth will be equal to mass multiplied 10. And this is a right rule. So, using the magic triangle, I can measure the value of mass and the value of weight. Using the magic triangle, I can measure the value of mass and the value of weight. So here I can say that mass on the earth equals weight on the earth divided by 10. Weight on the earth, and this is a new rule which will be applied here. This is your first time to apply this rule. حضرتك أول مرة هتطبق الرول ده. I can use the magic triangle or I can write the rule in a one step. You can write this rule in one step. So, the mass on the earth equals weight. The weight is given here. You already have the value of weight. You already have the value of weight. This value of weight will be in one step. It will be divided by 10. So it will be 600 divided 10. It will be 60 kilograms. And for the other two parts, I will not answer it because you can answer them. And now to the end of our session. Thanks for watching. Study well. And if you have any questions, you can ask your class teacher. See you later in other videos.